Dear audience, thanks for checking our work. We propose a collision-aware grasping pipeline for target-driven object grasping in constrained environments. The widely used 3-DOF grasping are often not feasible in this problem, and more flexible 6-DOF poses are required. However, typical 6-DOF object grasping systems overlook the same context. They rely on the prior knowledge and intensive planning computation, which is ungeneralizable and inefficient. Our approach generates collision-free and stable grasp poses, and therefore increases the efficiency and accuracy of grasping. The perception module takes an RGBD image of the scene and the query image of the target object as inputs. Then it localizes the target object from the segmented instances using both RGB and depth information. Then the target point cloud P and structure point cloud P' can be obtained by back projection. Next, we randomly sample a set of n6-DOF grasp poses over P. Then the spatial relationship between the robot hand and all the structure is encoded in P' by transforming P' with the grasp pose. The structure voxel grid V' is generated by voxelizing the transformed point cloud P'. The CARP then evaluates V' to determine the collision-free probability PC. Meanwhile, the grasp stability predictor encodes the object shape with respect to the grasp pose in the same manner, and then evaluates the stability of each grasp poses based on the transformed object voxel grid V. The final grasp pose is selected to maximize the overall grasping feasibility PF. The simulation experiments test our approach in various scenarios and arrangements. The results show that our approach is able to propose collision-free solutions in different surrounding structures and improves the performance significantly in challenging arrangements. The real robotic experiments demonstrate the effectiveness of our approach in the real world. Compared to the standard arrangement, the challenging arrangement increases the demand for collision awareness, which is crucial for real-world applications. We further test if our approach is generalizable to novel objects and surrounding structures. In these settings, the generated grasp poses avoid the randomly located books and successfully grasp novel objects.